Hello class and welcome to our unit on topographic maps. This is part 1 and we will be discussing today the map scale, straight line distance, and curved line distance. Now we've all seen maps that look like this, and this is essentially what we're going to be covering in this unit. Okay, a topographic map. Okay, here we see Mount St. Helens. Okay, we see a lot of lines going around it with numbers that are distinguished on those lines. Okay, by the end of this unit, okay, you guys will understand how to read this map, okay, with the lines as they're close or far apart, the shape of the lines, okay, and what the number values mean. So what is a map? A map is a snapshot of a particular area. Fields do not end at the edges of the map, okay? In other words, okay, it's just a snapshot of a small area, okay, and that the map actually, if we could zoom out on a paper map, okay, it would show other areas as well. Okay, and all good maps have a map scale. Okay, if you look at page three in your reference tables, okay, the state of New York, okay, there's a map scale in there in kilometers and miles. Okay, and another definition for field would be a term or anything being measured. So to determine the distance between two locations on the map, okay, we're going to use the map scales. Now the map scale is the part of the map usually at the bottom. Okay, generally we see on the bottom right hand side of the map. Okay, that gives you the distance in miles and or kilometers. Okay, you'll see that on the bottom of page 3, you have it both in miles and kilometers. Now if the map scale is in kilometers, the contour interval, which we're going to talk a little bit later, okay, is going to be measured in meters. Okay, so kilometers, meters, and if the map scale is measured in miles, that our contour interval elevations are going to be in feet. So those are just two things that go along together. And we'll discuss a little bit more about that when we get to the contour lines and iso lines unit, part of this unit. So there are two different ways of determining distance. Okay, imagine if you were to come to school, okay, you'd have to drive on the roads, okay, take a bunch of turns, okay, or let's say if you had a helicopter, okay, you could avoid all those turns and do a straight line. So the first one we're going to talk about is the straight line distance. Okay, that means determining the distance of a straight line drawn between two locations. Okay, and we're going to show you how to practice that. The other one, okay, taking all the roads and turns, okay, would be a curved line distance. Okay, this is more of an accurate measurement of how far something is. Okay, if you're going on a hike, okay, you can't just walk straight up the mountain. Okay, sometimes you're going to take a lot of turns based upon different landscapes or streams or rivers that might be in the way. So we're going to look at both of these today. Okay, a curved line distance is determining the distance along a curved road, okay, such as a road, tracks, trails, and rivers. So how do we determine the distance between 2 points using a map? Okay, the first step for a straight line. Okay, to determine the distance between the locations on a map, you'll need a piece of scrap paper. Okay, you see that we're going to probably do this when we have our in-school session. 1, you're going to place a scrap paper, okay, or place a scrap paper on the straight line between the two locations. You may have to use your imagination sometimes if the line is not drawn for you. So as you see on the map on the right-hand side, they have spot A and spot B identified, and they made marks to distinguish where those locations were. Notice how it did not follow a road. It was just a straight edge from one point to the other. Next, you're going to make the marks on the edge of the scrap paper at the two locations, just like they did in the map to the right. 3, you're going to move that scrap paper after you have the marks to the map scale on the bottom of your page, so that one of the marks is lined up with the 0. And you see that on the scale to the right, where they have A lined up with 0. And now we can see how far B is in a straight line. Okay, so the other mark indicates the distance, which for this example, okay, would be 4 miles. So let's go through some examples here. So we're going to determine the straight line distance between the given points using the map below. Now, if we look at map point A and point B, okay, the first step is I'm going to take a piece of straight paper and put it along both of those points. Second step is I'm going to mark both of those locations, A and B. After I've marked those locations, I'm going to move my scrap paper down to the scale at the bottom of the map. Now notice that the scale at the bottom of the map is measured in kilometers. Okay, because I'm going to cover that up once I move my paper. Okay, now I see where I put the 1 point at 0, and I can see how far that distance measures. Okay, it's 4. Now it is 4 kilometers. Okay, because we see that it says kilometers on the bottom of the scale. So we have 4 kilometer difference. We're going to do the same thing for B and C. Now we could make a prediction, okay, looking at the difference between A and B and C, that B and C might be a little bit closer. Okay, so let's see. If I put my piece of paper up between B and C, second step, I'm going to make my marks for B and C. Sometimes it helps you to write on the marks the actual location. If I would write B underneath the left mark and C underneath the right mark. I'm going to move it down to my scale. And I see I put one mark at 0 and one other mark's a little bit farther ahead than 3. Okay, remember our units are in kilometers. So when I put down my distance, okay, I think about 3.2 kilometers would be an accurate measurement. And that is less than the distance between A and B. Okay, let's do another example. C and D. Okay, we see that C and D is even closer than B and C are together, so we know our values getting smaller. I'm going to put my piece of paper up between C and D. I'm going to mark the locations. C, D. Then I'm going to move my scrap paper down to the scale. Now I see that it's put 1 point at 0. The other part marks at 2. Okay, so our answer for this would be 2 kilometers. Okay, D and E. Okay, now it looks like it's spreading out a little bit more. I'm going to place my paper along the 2 points. I'm going to mark D, mark E, move my paper down to the scale, and I see that it is again at 4 kilometers. So the distance between A and B turned out to be the same distance as D and E, 4 kilometers. So let's look at curved line distance. Okay, curved line distance requires a little bit more finesse, okay, and a little bit more work. So to determine the distance between locations on a map, you will need a piece of scrap paper. Okay, just like we did for the straight line distance. You're going to place the scrap paper on the straight line nearest your starting point and mark the location of your starting point on the edge of the scrap paper. Okay, I'm going to read through these and then we'll go over them. Okay, it'll make a little more sense when I give you guys the visual. Okay, you're going to mark on the edge of the scrap paper where the first straight line distance ends. Okay, make a mark on the map at this exact location. 3, you're going to pivot the paper so that the line ends up on the straight line of the feature. Now that feature might be a road or a trail that you're following. So you're going to be basically following the trail or following the road with your paper, just extending that line. Make a mark where this straight line distance ends. And you're going to continue this until you have reached your ending point. Now you're going to move your scrap paper just down to the scale like we did with the straight line distance, and we're going to line it up with a 0. Okay, and then the ending point indicates the distance of the entire curved line. So let's see some examples of this. Okay, determine the length of the Green River from point A to point F. Now we see point A to the top left of our map. We see F to the bottom right. But the Green River is not a straight river. Okay, there is a curve. There's a couple curves in it. So we're going to put our paper up by A. Now we see from A, okay, it is not a straight line. We're going to mark where A is, and then we're going to also mark where it goes straight till. See how it went straight to that point there? We're going to mark our paper again. We're going to turn, or as it said in our instructions, we're going to pivot the paper so it gets another straight line as we follow the river down. And we're going to keep making marks. Now, notice the marks on the map. The marks on the map help us see where we left off. So we're going to turn it and make sure that those marks line up with our last straight line measurement. We're going to continue going through the straight lines. You got a nice long section there until we get to our final point. Now you can see when we're at F, okay, we marked F, but if we look at our beginning point, it's a little bit beyond A. So our curved line distance would be a lot longer than our straight line distance. So we're going to move this down to our scale. We're going to start at 0, and we're going to mark where 4 kilometers is. Now, this distance is a lot larger than a scale, so we're going to have to use our scale a couple times. And we're just going to have to move our paper along with the scale. So we're going to first mark 4 kilometers. Then we're going to slide the piece of paper to the left. We're going to mark another 4 kilometers. So we're at total, we're about 8 kilometers now. And then we're going to move the paper a little bit to the left again. And we see that we are about between 2 and 3 at about 2.5. So what we're going to do is we're going to add 4 kilometers plus 4 kilometers plus 2.5. And the total distance, curved line distance of the Green River between A and F is going to be 10.5 kilometers. Okay, now using your earth science reference tables and a piece of scrap paper, determine the straight line distance between the following 2 cities in both miles and kilometers. Notice each city is located at a point near the name on the city. So what I'm going to do is I'm going to review this with you guys. Okay, and you guys are going to watch, and then when you guys come to class, okay, or we'll send home a piece of paper for you guys to work on this. Okay, so you get some practice. So the first one is Elmira and Binghamton, and they want the answer in kilometers and miles. So Elmira, okay, is to the left there, Binghamton's to the right. So this is a pretty small section. We're going to mark Elmira, mark Binghamton. Okay, the scale is to the bottom right. We see that in miles, okay, it's between 40 and 50. Okay, so it's going to roughly be about 40, kilometers first. So let's go back. Okay, it's 60, then the 70 is where it turns back to white, and then we have 80 at the end. So it's a little bit more than 70. So that's why we saw 72 miles. Okay, and then 72 kilometers. And it's roughly about 45 miles, as I said before. Okay, going to Syracuse and Oswego. Syracuse is pretty much in the center of New York State, and then we have Oswego up by Lake Ontario. We're going to mark both points. Okay, now I know we're going to start with kilometers first as our answer. It's a little bit more than 40, but a little bit less than 50. So it might be around 45. We look at the miles, it's a little bit heavy on the 20s, getting close to the 30s. So this is going to be 45 kilometers and 28 miles. Ithaca and Utica. Ithaca is at the bottom of the Finger Lakes. Utica is just south of the Adirondack Mountains. Okay, this one's distance is a little bit further. So we're going to mark both our locations for our straight line distance. And we notice that it's longer than our scale. So we're going to mark where 80 kilometers is and also where 50 miles is. We're going to move it over. So it's 80 plus about 42, So, yep, 42. So that turns out to be 122 kilometers. If we go back and look at the miles of this, okay, I got my points again. Okay, we have our 50 miles plus an additional 27. So that's a total of 77 miles. Okay, remember these are straight line distances. Okay, so if you were to go out on a hike, okay, and you're using the map below to plan your hike, okay, what is the approximate distance, okay, that you would take from C to D? Now, as a hiker, you're going to try to stay on the trail, okay, and you're going to label it with the correct units. Now, before we said when our scale is in miles, okay, our contour line is going to be feet, but we're not going to worry about that right now. So first, we're going to start at C. We're going to mark where C is, and this is going to be our curved line method. Mark C, mark how far as it goes straight on that trail. Okay, we're going to mark our paper so we know where to pivot from. Follow another straight line. Mark where it pivots. And we're going to continue this until we get all the way to D. So when we put up to our scale, we see where 3 miles is. We're going to move our scale to our piece of paper to the left. Okay, and we see another 3 miles. Okay, so 3 plus 3 is going to be a total of 6 miles in length for that hike. Okay, using earth science reference tables, page 3, and a piece of scrap paper, determine the entire length of the Genesee River that is shown on the map in both miles and kilometers. So the Genesee River is in western New York. Okay, it starts in Lake Ontario, or it starts in Pennsylvania, and it goes into Lake Ontario. Okay, and you can see we're going to start at where it's on the map, okay, which is in Pennsylvania, and we're going to measure the length of it. Okay, from here to here, we have a pretty long straight line. Okay, we're going to continue turning it from the pivot point, get another straight line there. Okay, so we only had 2 turns that we really used. In kilometers, in miles first, okay, it's 50 miles. We're going to move our slide over once we have our 50 mark, and we see it's another 50 miles to there. But there's a little bit left, so we're going to move it over, okay, and we have about between 0 and 10, about halfway, so it's another 5 miles. So our answer is 50, so I'm going to go back, 50 plus 50 plus 5, which is 105 miles. Now, it also asks for your answer in kilometers. So we're going to go back to our map. Okay, we're going to get our points. Okay, you should already have this from when we did miles. And we're going to measure in kilometers. Okay, starting with our point at 0, we measure out 80 kilometers. We're going to move our piece of paper. We're going to get another 80 kilometers. And then we're going to shift our paper again because we have a little bit of a gap left. And we see it's a little bit more. It's from 0. Okay, it doesn't quite hit that 10 mark. Okay, or it's close enough that we're going to say it's 10. So 80 plus 80 plus 10. Okay, so 80 plus 80 is 160, plus 10 is 170 kilometers. Okay, so that will conclude our part 1